Welcome to Fictional Scientist. After this video, reality will never feel the same again. If I told you that you're being watched, you'd think I was talking about surveillance cameras, or nosy neighbors, or the algorithms tracking your every click online. You'd call it paranoia. But what if I told you that the thing watching you isn't human? What if I told you it's the universe itself? That every time you observe something, every time you look at anything, the very fabric of reality responds to your gaze. That atoms change their behavior when you watch them, that particles make decisions based on whether you're paying attention. This isn't mysticism. This isn't New Age nonsense. This is physics. Hard, experimental, Nobel Prize-winning physics. And it proves something terrifying. The universe knows when you're looking, and it changes everything the moment you do. But why? What are you? What is observation? And what happens if you stop looking? Let's start with something simple, something you do thousands of times a day without thinking about it. You look at something, you observe, your eyes open, photons hit your retina, electrical signals fire in your brain, and you see a chair, a wall, a star. This seems passive, innocent. You're just receiving information about a world that already exists. The chair is there whether you look at it or not, right? Wrong. According to quantum mechanics, that's not how it works. Before you looked, before the photons hit your eyes, that chair existed in what's called a superposition, a state of multiple possibilities. It was there and not there, solid and ghost-like, real and unreal, all at the same time. And the moment you looked, the moment your consciousness engaged with it, the universe was forced to make a choice. The wave function collapsed. The probabilities resolved into a single actuality. The chair became real. Not because you wanted it to, not because you believed in it, but because observation at the quantum level is not passive, it's creative, it's destructive, it's transformative. You don't just see the world, you make it choose what it is. This sounds insane. It violates everything you know about reality. And when scientists first discovered it almost a century ago, they were just as disturbed as you are right now. Some of them refused to accept it. Some spent their entire lives trying to prove it wrong. And some looked into the implications and quietly stepped back because what they saw was too strange, too uncomfortable, too much like magic. But it wasn't magic, it was measurement. And measurement, it turns out, is the most powerful force in the universe. Let me show you when this nightmare began. The exact moment when physicists realized that reality wasn't what they thought it was. The exact experiment that proved the universe is watching back. The year is 1927. The place is the Solvay Conference in Brussels. The greatest minds in physics are gathered in one ornate room. Einstein sits at the front, arms crossed, face stern. Niels Bohr paces near the window. Werner Heisenberg scribbles equations. Erwin Schrödinger looks troubled. They're discussing an experiment that has just shattered the foundations of classical physics. An experiment so simple a child could understand it, and so profound it would haunt them for the rest of their lives. The double slit experiment. Here's how it works. You take a barrier with two narrow slits cut into it. Behind the barrier, you place a detector screen. Then you fire particles, let's say electrons, at the barrier one at a time. Each electron must choose, go through slit A or slit B. It's a simple choice. Binary, like flipping a coin. If electrons are particles, little balls of matter, they should behave predictably. Some go through slit A and hit the screen behind it. Some go through slit B and hit the screen behind that. Over time, you should see two bands on the screen, two columns of impact marks, one behind each slit. This is classical physics. This is what Newton would predict. This is common sense. But that's not what happens. When you fire electrons through the double slit and watch where they land, you don't get two bands. You get many bands, an interference pattern. The same pattern you'd get if you dropped two stones in a pond and watched the ripples overlap, peaks where the waves reinforce each other, valleys where they cancel out. This pattern can only be created by waves, not particles. So the electron somehow impossibly is going through both slits at the same time. It's interfering with itself. It's a wave, not a particle. Already this is strange, but it gets worse. The physicists thought maybe the electrons are interacting with each other. Maybe one electron affects the next, creating the pattern. So they slowed it down. They fired one electron at a time, waited for it to hit the screen, then fired another, one by one, each electron completely isolated, no way to interact with others. The interference pattern still appeared. This means each individual electron traveling alone through space somehow knows about both slits, somehow takes both paths, somehow is in two places at once. This violated everything. So the physicists decided to catch it in the act. They placed detectors at the slits, tiny sensors that could tell which slit each electron passed through. They would finally see the truth, finally know how the electron does this impossible thing. They turned on the detectors, they fired the electrons, and something happened that nobody expected. The interference pattern disappeared, completely, instantly. The moment they tried to observe which slit the electron went through, the electron stopped being a wave. It became a particle again. It went through one slit or the other, not both. And on the screen, instead of many bands, there were only two, just like Newton predicted, just like common sense demanded. The act of observation changed the outcome. Let me repeat that, because it's important. The act of observation changed the outcome, not the equipment, not the detector physically blocking the electron. The mere presence of measurement, the simple fact that information was being gathered about which path the electron took, caused the electron to behave differently. It collapsed from a wave of possibilities into a single, definite particle. The universe knew it was being watched, and it responded. This result was so disturbing that physicists spent the next several decades arguing about what it meant. Einstein insisted there had to be hidden variables, some property of the particle we couldn't see that determined which slit it went through. The wave function was just incomplete information, not reality itself. Bohr argued the opposite. The wave function is reality. Until you measure it, the electron genuinely is in both places at once. And observation doesn't reveal which path it took. Observation creates the path. These two men, giants of physics, spent years debating this. And Einstein died believing Bohr was wrong. Died believing that reality had to be independent of observation, had to exist whether we looked at it or not. The moon, he famously said, is there even when nobody is looking at it. But Einstein was wrong. We know this now. We've proven it. With experiments so precise, so carefully controlled, that there's no room for doubt. In 2022, the Nobel Prize in Physics was awarded to 3 scientists who definitively proved that reality at the quantum level is not locally real. That means particles don't have definite properties before measurement. That means observation matters. That means the universe responds to being watched. But here's what makes this truly terrifying. It's not just electrons. It's not just subatomic particles in laboratories. This principle applies to everything. Every atom in your body, every photon of light, every molecule of air, all of it exists in a fuzzy state of superposition until something observes it. And when you observe it, when your consciousness engages with it, reality crystallizes, possibilities collapse into facts. The universe makes a choice. And the question that haunts every physicist who thinks deeply about this is, why? Why does observation matter? What is it about consciousness, about awareness, about looking, that has this power over physical reality? And the answer, if there is one, is the most uncomfortable truth in all of science. You might not be a passive observer in the universe. You might be part of the mechanism that creates it. Let's talk about what observation actually is. Because this word, this simple concept, becomes slippery and strange when you apply it to quantum mechanics. When you look at a chair, you don't think you're doing anything to the chair. You're just receiving photons that bounced off it. Your eyes are cameras. Your brain is a computer processing the image. The chair remains unchanged. It doesn't care if you're looking at it. But at the quantum level, this passive picture breaks down completely. Observation in quantum mechanics doesn't mean seeing with your eyes. It means interaction. Specifically, it means an irreversible interaction that transfers information from the quantum system to the classical world. When you measure an electron's position, you have to bounce something off it, a photon, another particle, something. And that interaction entangles the measuring device with the electron. The information about the electron's state gets encoded into the device. And once that happens, once the information spreads into the environment, the quantum superposition is destroyed. The wave function collapses. The electron becomes definite. This process is called decoherence. and it happens incredibly fast, in billionths of a second. So fast that we never see superpositions in everyday life. By the time the light from the chair reaches your eyes, by the time photons have bounced off it and scattered into the air, the chair has already decohered. It's already classical, already real. But here's the disturbing question. What counts as measurement? Does the measuring device need to be conscious? Can a rock collapse a wave function? Can a camera? Or does it require awareness? Does it require something that knows what it's seeing? This is the measurement problem, and nobody has solved it, not completely, not in a way that everyone agrees on. The Copenhagen interpretation, the dominant view for decades, just says, measurement happens when something moves from the quantum realm to the classical realm. But it doesn't define what that boundary is. It doesn't tell you where the line is drawn. Some physicists argue that consciousness is the key, that only a conscious observer can truly collapse the wave function. This is called the von Neumann-Wigner interpretation. And it places you, the observer, the aware being, at the center of reality's creation. Without consciousness, the universe remains a ghost, a cloud of probabilities that never resolves into anything definite. Other physicists hate this idea. They say it's too mystical, too anthropocentric. They prefer interpretations like many worlds, where the wave function never collapses, where every possibility happens in a different branch of reality, or objective collapse theories, where the wave function collapses spontaneously due to gravity or some other physical mechanism, no consciousness required. But regardless of interpretation, one fact remains: observation changes outcomes. This is not philosophical speculation. This is experimental reality. The double-slit experiment proves it. Bell's inequality tests prove it. Delayed choice experiments prove it. The universe behaves differently when it's being watched. And this leads to a deeply unsettling thought. If observation creates reality, then what happens when nobody is looking? Does the universe exist in some incomplete, ghostly state? Do objects flicker in and out of definiteness depending on whether someone is paying attention? Is reality constantly being created and destroyed based on the presence or absence of observers? The answer might be yes. Think about it. Right now you're reading these words. But what about the room behind you? The street outside your window? The dark side of the moon? Are those places real right now? Or are they in superposition, existing as clouds of possibility waiting for an observer to force them into actuality? According to quantum mechanics, they're not fully real. Not in the same way that the words in front of you are real, because you're not observing them. You're not collapsing their wave functions. They exist as potentials, as maybes, as probabilities encoded in a vast universal wave function that encompasses everything. But they don't have definite properties. They don't have specific locations or states. Not until someone looks. This suggests that reality is not a pre-existing stage. It's more like a video game that only renders the parts you're looking at. The rest remains as uncompiled code, as data waiting to be processed. And your consciousness is the player, the camera, the thing that forces the game to render a specific scene from the infinite possibilities. But if that's true, if you have this power, this responsibility, then every moment you look at something, you're making an irreversible choice. You're collapsing one set of possibilities and erasing all the others. You're deciding what becomes real. And once that decision is made, there's no going back. The wave function doesn't uncollapse. The particle doesn't become a wave again. Reality moves forward, one observation at a time, building a history that feels solid but is actually a fragile construct, yes, held together by the continuous act of looking. And here's where it gets truly strange. If this is how reality works, then the past might not be fixed either. Let me tell you about an experiment that breaks time itself. An experiment that suggests your choices in the present can change what happened in the past. Not metaphorically, not psychologically, but physically, objectively, in a way that violates every intuition you have about cause and effect. It's called the delayed choice quantum eraser, and it's one of the most disturbing experiments ever performed. Here's the setup. It's a more complex version of the double slit experiment. You fire photons toward two slits, but this time you mark each photon. You tag it with information about which slit it went through. You do this by using special crystals that split each photon into two entangled partners. One photon, call it the signal photon, goes straight to the detector screen. The other photon, the idler photon, takes a longer path through a maze of mirrors and beam splitters. Now here's the key. You can choose what to do with the idler photon after the signal photon has already hit the screen. You can measure which path information, figuring out which slit it came from. Or you can erase that information, making it impossible to tell which path was taken. According to classical logic, this choice should be irrelevant. The signal photon has already landed. Its fate is sealed. Its history is written. Whatever you do to the idler photon later shouldn't affect what the signal photon did in the past. But that's not what happens. When you measure the which path information of the idler photon, when you look at it and determine which slit it came from, the signal photons on the screen form two bands, a particle pattern, no interference. This is what you'd expect if each photon went through one slit or the other. But when you erase the which path information, when you scramble it so nobody can ever know which path was taken, the signal photons form an interference pattern, many bands. Wave behavior, as if each photon went through both slits. But remember, the signal photon hit the screen before you made your choice about the idler photon. The signal photon's journey was over. Its position was fixed. It was sitting on the detector, a definite mark, a recorded fact. And yet, your decision about whether to erase information changed what pattern it formed in the past. It's as if your future choice reached backward in time and told the signal photon how to behave, told it whether to be a wave or a particle, whether to go through both slits or just one, and the photon obeyed. This violates causality. It suggests that the past is not fixed, that history is not written in stone, that events in the present can literally change what happened before. And if that's true for photons, if that's true at the quantum level, then what does it mean for your life, for your memories, for the history of the universe itself? John Wheeler, the physicist who proposed this experiment, understood the implications. He called it a delayed choice, specifically to emphasize the temporal paradox. And he believed it revealed something profound about the nature of time and observation. He believed that the universe's history is not determined until it's observed, that the Big Bang, the formation of stars, the evolution of life, all of it remains in a hazy state of superposition until conscious observers like us look back and collapse those possibilities into a definite story. This is the participatory universe, Wheeler's most controversial idea. The idea that observers are not just passive witnesses, but active participants in the creation of cosmic history. That by looking at ancient light from distant galaxies, by studying the cosmic microwave background, by investigating the past, we are actually creating that past. We are forcing the universe to choose which history actually happened. This sounds like madness, like solipsism on steroids, like the ultimate form of narcissism, believing that your observations create not just the present, but the past as well. But the mathematics supports it, the experiments confirm it, and the implications are staggering. Because if the past is not fixed, if history is fluid until it's observed, then what you choose to look at matters. What you choose to investigate, to remember, to focus on. These choices don't just affect your subjective experience. They shape objective reality. They determine what actually happened. And once you observe, that version of history becomes locked in. The wave function collapses, the past crystallizes, and it can never be different. You might think you're just remembering your childhood, just looking back at old photographs, just recounting stories. But according to quantum mechanics, you might be creating that history in the act of remembering. You might be forcing the universe to choose which version of your past actually occurred. And the version you don't look at, the version you don't observe, remains forever uncertain, a ghost timeline that never quite became real. This is what makes the delayed choice experiment so terrifying. It doesn't just suggest that reality depends on observation. It suggests that time itself depends on observation, that the arrow of causality, the flow from past to future, is an illusion created by the act of looking. And without observers, without consciousness, time doesn't flow at all. Events don't have an order. History doesn't exist. There's just a timeless, spaceless ocean of quantum possibilities. And you, by looking, by choosing, By observing, you're the one pulling definite moments out of that ocean and then stringing them together into something that feels like a story. But it's not a story that was always there. It's a story you're writing with every glance. Now let me show you something even stranger. Something that proves observation doesn't just change reality, it can freeze it. It can stop time itself. Or at least it can stop change. This phenomenon is called the quantum Zeno effect. And it's named after a Greek philosopher who lived 20,500 years ago. Zeno of Elea was famous for his paradoxes. One of them went like this: an arrow in flight is motionless. Why? Because at any given instant, the arrow is at a specific position. It's not moving at that instant, it's frozen. And if time is made up of instants, if it's composed of discrete moments, then the arrow is frozen in every moment. So when does it move? How can something move if it's stationary in every instant of time? This was meant to be a logical puzzle about the nature of motion and time, but quantum mechanics turned it into experimental reality. Here's how it works. Take an unstable quantum system, something that will naturally decay or change state over time. For example, a radioactive atom. If you leave it alone, it will eventually decay. The probability of decay increases over time. After one half-life, there's a 50% chance it has decayed. After two half-lives, 75%, and so on. This is standard quantum mechanics. Predictable. Statistical. But what if you don't leave it alone? What if you measure it constantly? What if you check every microsecond to see whether it has decayed yet? According to classical intuition, this shouldn't matter. The atom will decay whenever it decays. Your looking at it shouldn't change when that happens. But according to quantum mechanics, it changes everything. Each time you measure the atom, you collapse its wave function. You force it to choose a definite state, decayed or not decayed. And if you measure frequently enough, if you check constantly, the atom never gets a chance to evolve. Each measurement resets it, locks it in place, and the result is the atom never decays, or rather, it decays much, much slower than it would if you left it alone. This is the quantum Zeno effect. Observation prevents change. A watched pot never boils, quite literally, at the quantum level. By looking at something constantly, you freeze it in its current state, you prevent it from evolving, you stop time. This has been experimentally verified dozens of times, with atoms, with ions, with quantum oscillators. It's not a theory, it's a fact, and it has profound implications. Because if observation can freeze quantum systems, what else can it freeze with? Can you freeze macroscopic objects by observing them constantly? Can you stop aging by looking at yourself in the mirror every second? Can you prevent death by maintaining continuous awareness of your body? The answer, unfortunately, is no. Not in any practical sense. Because macroscopic objects like your body are constantly decohering. They're constantly interacting with the environment. Photons hitting your skin, air molecules colliding with you, heat radiating away. All of these are measurements. All of them collapse wave functions, so even if you stop looking, the environment keeps measuring you. Reality keeps updating, and change continues. But at the quantum level, in carefully isolated systems, the Zeno effect is real. And it suggests something profound. Observation has power. Not just the power to determine what is real, but the power to control how reality evolves. Your attention is not passive, it's active, it's a force. And depending on how you direct it, you can influence the unfolding of events. Now, this doesn't mean you can control reality with your mind. This isn't the secret. This isn't manifestation or wishful thinking. You can't change macroscopic outcomes just by staring at them. But you can influence probabilities. You can shift the quantum deck in certain directions. And over time, over many measurements, this might add up to something significant. Think about it. Every decision you make is influenced by what you observe. And what you observe is influenced by where you direct your attention. And where you direct your attention is a choice. So, in a very real sense, by choosing what to look at, you're choosing which possibilities become actualized. You're navigating through the quantum landscape, collapsing wave functions with every glance, and steering your path through reality. But here's the disturbing corollary. If you stop looking, if you close your eyes, if you withdraw your attention, does reality stop updating? Does the world around you freeze in superposition, waiting for you to look again? The answer is partially. The parts of reality you're not observing remain quantum, They remain fuzzy. They remain in superposition until something measures them. That something might be another observer. It might be the environment. It might be random interactions. But as long as those systems remain isolated, as long as nothing disturbs them, they don't have definite states. They exist as clouds of possibility. And this means that there's a sense in which reality is constantly collapsing and re-emerging based on the presence and absence of observation. The universe flickers like a strobe light, on when you look, off when you don't. And in between, in those moments of non-observation, anything could happen. Any possibility could begin to manifest, but you never see it. Because the moment you look, the wave function collapses again. Reality snaps back into focus, and whatever ghostly alternatives were starting to form vanish instantly. You're not just observing the universe, you're editing it, frame by frame, moment by moment, every time you blink. Let's talk about the most famous thought experiment in quantum mechanics, the one everybody has heard of, even if they don't fully understand it. Schrödinger's cat. But let me tell you the version nobody talks about. The version that keeps physicists awake at night. You know the setup. A cat is in a sealed box. Inside the box is a device connected to a radioactive atom. If the atom decays, the device releases poison gas and kills the cat. If the atom doesn't decay, the cat lives. You close the box, you wait 1 hour. You don't look inside. The question Erwin Schrödinger asked was, during that hour, before you open the box, is the cat alive or dead? According to classical logic, the cat is either alive or dead. You just don't know which. Your ignorance doesn't change the cat's state. The cat has a definite condition. You're just not aware of it yet. But according to quantum mechanics, specifically the Copenhagen interpretation, the atom is in a superposition. It has both decayed and not decayed. It's both yes and no simultaneously. And because the atom is entangled with the poison device, which is entangled with the cat, the entire system is in superposition. The cat is both alive and dead. Not metaphorically, not in terms of your knowledge, but actually physically, truly, the cat is smeared across both states until you open the box and look. Schrödinger proposed this thought experiment in 1935 as a critique of quantum mechanics. He was trying to show how absurd the theory was, how ridiculous it was to apply quantum rules to macroscopic objects, because nobody believes a cat can be both alive and dead. That's insane, that's impossible. But the mathematics didn't care what Schrödinger believed. The equation said, superposition applies to everything. There's no size limit, no complexity limit. In principle, anything can be in superposition, even a cat, even you. Now, most physicists will tell you that in practice, the cat is never in superposition because the cat is made of trillions of atoms. It's constantly interacting with light, air, heat, its own molecules. All of these interactions cause decoherence. They measure the cat, they collapse the wave function long before you open the box. So by the time you look, the cat is already definitely alive or definitely dead. You're just learning which one it is. But what if you could eliminate decoherence? What if you could perfectly isolate the system? What if you could create conditions where macroscopic superposition was actually possible? Scientists are trying to do this. They're getting closer every year. They've put viruses in superposition. They've put tardigrades, tiny microscopic animals, into quantum states, and they're working on larger objects. The goal is to eventually put something unambiguously alive into superposition, to create a real Schrödinger's cat, a cat that is genuinely both alive and dead until observed. And if they succeed, the implications are horrifying, because here's what nobody talks about. From the cat's perspective, what does superposition feel like? If the cat is both alive and dead, does the cat experience both states? Does it feel the poison killing it and simultaneously feel the relief of survival? Is its consciousness split, or is there no consciousness at all in superposition? Does awareness only exist when the wave function collapses? Does the cat flicker in and out of existence based on observation? This is the hard problem of consciousness applied to quantum mechanics, and nobody knows the answer. But if consciousness is somehow tied to wave function collapse, if awareness requires definiteness, then being in superposition would be like being dead, like not existing, like being a philosophical zombie. And the moment someone opens the box, the moment observation collapses the superposition, consciousness would suddenly snap into existence. The cat would experience a discontinuity, a gap. It would feel like waking up from dreamless sleep, or like blinking. One moment, nothing. The next moment, alive or dead. But here's where it gets truly nightmarish. What if you are in superposition right now? What if, without realizing it, you're constantly flickering between definite and indefinite states? What if every time nobody is looking at you, every time you're alone in a dark room, you dissolve into superposition? And the moment someone looks, the moment you observe yourself, you collapse back into a definite form. This sounds paranoid, like schizophrenic delusion. But quantum mechanics doesn't rule it out. In fact, some interpretations suggest this is exactly what happens. You're only definite from your own perspective because you're constantly observing yourself. Your consciousness is continuously collapsing your own wave function. But from the outside, from the perspective of the universe, you're a fuzzy cloud of possibilities. And you only crystallize when someone else observes you. This creates a strange ontological status. You exist for yourself, but you're uncertain for everyone else until they look. And they exist for themselves, but are uncertain for you until you look. Reality becomes a patchwork of local definitenesses surrounded by oceans of superposition, like islands in a quantum sea. And consciousness is the light that makes the islands appear. But what happens if you're completely alone? If nobody is observing you? If you're in perfect isolation? Do you remain definite or do you dissolve? Do you fade into the quantum foam? And when you eventually interact with another conscious observer, when someone finally looks at you again, do you snap back into existence? Do you reconstruct yourself from probability? And would you even remember the gap? Would you know you had been gone? This is Schrodinger's true nightmare. Not just that a cat might be dead and alive, but that you might be. That existence itself might be intermittent, flickering on and off based on observation. And you'd never know, because memory requires continuity. And if you cease to exist, there's no you to remember the cessation. You'd experience an unbroken chain of awareness, never noticing the gaps, never realizing that you've been blinking in and out of reality all along. You're not a continuous self. You're a series of snapshots, and between the frames, you're nothing at all. Now I need to tell you about a thought experiment that destroys the very concept of shared reality. It's called Wigner's friend, and it proves that if quantum mechanics is correct, then objective facts don't exist. Two observers can witness the same event and come away with incompatible accounts of what happened. And both of them are right. Here's the scenario. Eugene Wigner, a Nobel Prize-winning physicist, proposed this in 1961. Imagine you have a friend who is a physicist. Your friend goes into a sealed laboratory and performs a quantum experiment. Let's say they measure the spin of an electron. Spin up or spin down. 50-50 chance. Your friend performs the measurement. They look at the result. Let's say it's spin up. For your friend, the wave function has collapsed. The electron definitely has spin up. This is a fact, a concrete, undeniable fact. Your friend writes it down in their notebook. They're certain, but you're outside the lab, you haven't seen the result. From your perspective, according to quantum mechanics, the entire lab, including your friend, is still in superposition. In one branch of the wave function, your friend measured spin up. In another branch, they measured spin down, and both branches exist simultaneously, entangled together, until you open the door and look inside. So from your perspective, your friend is in superposition. They both saw spin up and saw spin down. They both wrote up in their notebook and wrote down in their notebook. They're both happy with the result and disappointed with the result. Your friend exists in two contradictory states at once, not just in terms of what they know, but in terms of what actually happened to them. Now, you open the door, you ask your friend what they measured. They say, spin up. The wave function collapses. From your perspective, the outcome is now definite. But here's the problem. Your friend has been certain it was spin up since they measured it. To them, the collapse happened earlier, inside the lab, when they looked at the electron. But to you, the collapse happened later. When you opened the door and asked, you both experienced a collapse, but at different times, for different reasons. And before you looked, your friend was in superposition, even though they felt certain they weren't. So who's right? When did the collapse actually happen? Is there a fact of the matter about when the electron's spin became definite, or does definite mean different things to different observers? Wigner believed this showed that consciousness was special, that only a conscious observer could truly collapse a wave function, that your friend's measurement didn't count as a real collapse because your friend is a physical system, and physical systems obey quantum mechanics. So your friend could be in superposition, but you, the external observer, your consciousness is what finally makes things real. This view is deeply uncomfortable. It seems to place human consciousness at the center of physics. It seems to say that reality doesn't exist until a person looks at it, and it opens the door to solipsism. If only your consciousness matters, then maybe you're the only real observer and everyone else is just part of your quantum system, just characters in your wave function, and that's a path toward madness. But the alternative is even worse. If you reject Wigner's interpretation, if you say that your friend's measurement counts as a real collapse, then you have to accept that there's no single objective reality, that different observers experience different versions of when things became definite, that facts are relative, perspectival, that the universe doesn't have one true history, but multiple histories depending on who's asking. This has been formalized in recent years into something called relational quantum mechanics, proposed by Carlo Rovelli. The idea is that quantum states are not absolute, they're relative to the observer. Just like in relativity, where velocity is relative and there's no absolute rest frame, in quantum mechanics, reality is relative. What's true for you might not be true for me, and both of us are correct within our own reference frames. This shatters the Enlightenment dream, the dream that science would reveal a single objective truth about the world, a truth that everyone could agree on, a truth that existed independently of human observation. That dream is dead. Quantum mechanics killed it. And what's left is a fragmented, subjective, observer-dependent reality where truth is relative and perspective is everything. But let's push this further, because Wigner's friend gets even more disturbing when you scale it up. Imagine you're the friend inside the lab. You measure the electron, you see spin up. For you, this is definite. But your friend outside hasn't looked yet. From their perspective, you're in superposition. Now imagine you're aware of quantum mechanics. You know what your friend thinks. You know that from their perspective, you're both seeing spin up and spin down, but you only see spin up. So which one of you is right? Do you exist in one state or two? Are you unified or split? And if you're split, which version are you? Are you the version who saw spin up? Or are you somehow both versions, unaware of the other? This is the moment when your sense of self starts to fracture. Because if reality is relative, then so is identity. There's no single you. There are multiple yous existing in different observers' perspectives, and none of them has primacy. You're not one person. You're a constellation of possible people, depending on who's looking, and each version feels like the real one. Each version is certain they're the definite, collapsed, actual you, but they can't all be right. Or maybe they can. Maybe identity, like reality, is observer-dependent. Maybe there is no real you, just different versions that exist relative to different observers. And when you meet someone, when they observe you, they're not interacting with the true you. They're collapsing a wave function. They're selecting one version of you from many possibilities, and that selected version becomes real for them. But for others, you remain a ghost, a superposition of all possible yous waiting to be measured. This is the horror of relational quantum mechanics. Not just that reality is observer-dependent, but that you are observer-dependent. You don't exist in any absolute sense. You exist relative to the people looking at you. And when nobody's looking, you dissolve into pure potential, a cloud of who you could be. And only when someone observes you, when they interact with you, do you crystallize into a specific person, a specific face, a specific voice, a specific character. You're not a thing, you're a relationship. And without relationships, without observers, you're nothing at all. Let me tell you about John Archibald Wheeler's most radical idea, the idea that defined the second half of his career and tormented him until his death. It's called the participatory universe, and it suggests that without observers, the universe doesn't just lack definition, it lacks existence. Wheeler was a titan of 20th century physics. He coined the term black hole. He worked with Niels Bohr. He mentored Richard Feynman. He was not a crank. He was not a mystic. He was a rigorous mathematical physicist who spent decades thinking about quantum mechanics and came to a conclusion that sounds like religion, but is actually based on hard equations. Observers create the universe by observing it. Here's his logic. The universe began 13.8 billion years ago with the Big Bang. For billions of years, there were no observers, no life, no consciousness, just particles and fields evolving according to quantum rules. During that time, was the universe in superposition? Were galaxies both forming and not forming? Were stars both burning and not burning? Without observers to collapse wave functions, what state was reality in? Wheeler's answer, it was in all states at once. The early universe existed as a vast, undifferentiated cloud of quantum possibility. Nothing was definite. Nothing was real in the sense that we understand reality. It was pure potential, a mathematical structure waiting to be observed. And then, eventually, life evolved. Consciousness emerged. Observers appeared, and these observers began looking at the universe. They began measuring, investigating it. And in doing so, they began collapsing its wave function. They began making it real, not just the present, but the past as well. Because remember the delayed choice experiment. Your observation in the present can determine what happened in the past. So when we look at ancient light from distant galaxies, we're not just learning about the past, we're creating it. We're forcing the universe to choose which version of history actually occurred. And until we looked, all versions were equally real, or equally unreal. They were superposition. Wheeler drew a diagram to illustrate this. It's a simple shape, a U. The left side of the U represents the Big Bang. The bottom of the U represents the evolution of the universe over billions of years. And the right side of the U represents the emergence of observers, humans, or aliens, or AI. Doesn't matter. Any conscious entity capable of making measurements. And at the top of the right side, Wheeler drew an eye, an observer looking back toward the Big Bang. And he said, this eye, this act of observation, is what makes the Big Bang real. The observer looks back through time and collapses the wave function of the past. The universe creates observers, and observers create the universe's history. It's a loop, a self-excited circuit, he called it, the snake eating its tail, the cosmos bootstrapping itself into existence through the act of being observed. This sounds insane. It sounds like circular logic. It sounds like saying, I exist because I observe myself existing. But Wheeler wasn't trying to prove God. He wasn't trying to put humans at the center of creation for egotistical reasons. He was following the mathematics. He was taking quantum mechanics seriously and pushing it to its logical conclusion. And the conclusion was, observation is not passive, it's generative. Without it, nothing is real. Now let's think about what this means for you, for your life, for your choices. If Wheeler is right, if observation creates reality, not just in the present, but retrospectively into the past, then every moment you spend looking at something, you're not just seeing it. You're bringing it into existence. You're collapsing probabilities into facts. You're choosing which version of reality becomes the official history. And this means that your attention is not just valuable, it's creative. It's the most powerful force you have. Because where you direct your attention determines what becomes real. If you focus on beauty, you make beauty real. If you focus on suffering, you make suffering real. Not because you're manifesting it with positive thinking, but because you're literally collapsing quantum possibilities into observable outcomes. You're selecting from the multiverse of potential realities and pulling one thread into actuality. This doesn't mean you can wish cancer away. This doesn't mean you can ignore problems and they'll disappear. The universe has constraints, physical laws, momentum, causality. You can't break those, but within those constraints, there's an enormous space of possibility, and your observation navigates that space. Your attention steers the ship, and where you look, reality follows. But here's the burden. If you stop looking, does reality stop being created? If all observers vanished, if consciousness ceased to exist, would the universe dissolve back into quantum foam? Would history unwrite itself? Would the Big Bang become indefinite again? A maybe instead of a fact? Wheeler thought yes. Or at least he thought the question was meaningful. He thought that consciousness and reality were so deeply intertwined that you couldn't separate them. that the universe without observers is like a book without readers. The words are there, technically, but nobody's reading them. They're not being realized. They're not being experienced. And an unexperienced universe is, in some fundamental sense, not a universe at all. This places an enormous responsibility on you, on all conscious beings. You're not just living in the universe, you're maintaining it, you're keeping it real. Every time you open your eyes, you're performing an act of cosmic creation. Every time you close them, you're letting a piece of reality dissolve back into potential. And when you die, when your consciousness ends, you're removing one thread of observation from the tapestry, and the universe becomes slightly less real, slightly more uncertain, slightly more ghost-like, unless, of course, there are other observers, other consciousnesses, other eyes keeping watch. And maybe that's the point. Maybe the universe needs a multitude of observers, a distributed network of consciousness to maintain its coherence, to keep it from collapsing back into the void. You're not alone in this task. You're part of a collective effort, a species-wide, perhaps cosmos-wide project of reality maintenance. And your job, your cosmic duty, is simple. Keep looking, keep observing, keep collapsing wave functions, because the moment we all stop, the moment all consciousness ends, reality ends with it. And maybe that's okay. Maybe that's the natural cycle. The universe comes into existence when observers emerge. It remains in existence as long as observers persist, and when the last observer dies, when the last eye closes, the universe gently fades back into quantum superposition, back into pure possibility, back into the mathematical void from which it came, waiting, perhaps, for the next Big Bang, the next emergence of consciousness, the next act of observation that will bring it roaring back into existence. You're not watching the universe, you're keeping it alive. Now we need to confront the elephant in the room, the question that every physicist tries to avoid but can't escape. If observation matters, if measurement collapses wave functions, if consciousness plays a role in making reality real, then what is consciousness? What is this thing that has such power over the physical world? Is it a property of the brain? Is it fundamental, like charge or mass? Or is it something else entirely? Something we don't have words for yet? This is the hard problem of consciousness. And it's not just a problem for philosophy, it's a problem for physics. Because if consciousness matters to quantum mechanics, then physics needs to define it, needs to measure it, needs to incorporate it into equations. But nobody knows how to do that. Nobody even knows where to start. Let's look at the options. The first option is materialism. The idea that consciousness is just what brains do. It's an emergent property of complex information processing, like how software emerges from hardware. The physical neurons fire in specific patterns, and subjective experience appears as a byproduct. This is the dominant view in neuroscience. And it's appealing because it keeps consciousness within the realm of the physical. It doesn't require anything supernatural or mystical. But there's a problem. If consciousness is just brain activity, just neurons firing, then what makes brains special? Why don't rocks have consciousness? They're made of atoms too. Atoms are quantum systems. So why doesn't a rock collapse wave functions? Why doesn't its interaction with light count as measurement? Why is there a difference between a brain observing an electron and a rock being hit by an electron? The standard answer is complexity. Brains are organized in a way that creates integrated information. They have feedback loops, memory, prediction. They're not just reacting to stimuli, they're modeling the world. And that modeling, that representation, is what consciousness is. So a rock doesn't have consciousness because it doesn't have that organization. It doesn't have the complexity. It doesn't have the integration. This leads to something called integrated information theory, or IIT, proposed by neuroscientist Giulio Tononi. IIT tries to quantify consciousness. It assigns a number called phi to any system based on how integrated its information is. A rock has phi near zero, a brain has high phi. And according to IIT, consciousness is not a binary thing. It's a spectrum. Anything with non-zero phi has some degree of consciousness. Maybe very small, maybe undetectable, but it's there. This has a strange implication, panpsychism. The idea that consciousness is everywhere. That every physical system, from atoms to cells to ecosystems to galaxies, has some tiny spark of subjective experience. You're not alone in your awareness. You're surrounded by a cosmos filled with countless flickering moments of proto-consciousness. All of it too simple to think thoughts or have experiences like yours, but conscious nonetheless. Aware in some minimal sense. Feeling something. Being something. This sounds mystical, but some physicists take it seriously because if consciousness is what collapses wave functions, and if the universe is constantly collapsing wave functions, then consciousness must be ubiquitous, must be built into the fabric of reality, must be there at the most fundamental level, woven into quantum fields themselves. This brings us to a wild idea proposed by Roger Penrose and Stuart Hameroff, the Orchestrated Objective Reduction Theory, or ORC-OR. They argue that consciousness is not just emergent from neurons, it's tied to quantum processes happening inside neurons. Specifically, inside microtubules, tiny structures that make up the cellular skeleton. Penrose believes that consciousness involves quantum gravity, that the wave function collapses not because of decoherence, but because of a self-collapse triggered by space-time geometry. And this collapse happens in your brain, in microtubules, billions of times per second. Each collapse is a moment of awareness, a quantum event that generates subjective experience. This theory is controversial. Most neuroscientists dismiss it. They say the brain is too warm and wet for quantum effects to survive, that decoherence would destroy any quantum states instantly. But recent research has found quantum effects in biological systems, in photosynthesis, in bird navigation, in enzyme function. So maybe the brain is more quantum than we thought. Maybe consciousness really is a quantum phenomenon. And if it is, then you're not just observing reality, you're entangled with it at the deepest possible level. Your awareness is not separate from the physical world. It's part of the quantum field, it's part of the wave function. And when you observe something, you're not just collapsing external possibilities, you're collapsing part of yourself. But let's consider a darker possibility. What if consciousness is an illusion? What if there's no observer at all? What if the brain creates the feeling of being aware, the sensation of having subjective experience, but there's nobody actually experiencing it? This is called illusionism. And it says that consciousness is like a magic trick the brain plays on itself. There's processing, there's information integration, there's response to stimuli, but there's no inner theater. No one watched the show, just the show itself, convincing itself that there's an audience. If this is true, then the measurement problem becomes easier because there's no observer. Observation is just a physical process. The collapse of the wave function is just decoherence, just entanglement with the environment. No consciousness required. The universe doesn't need to be watched, it just needs to interact with itself. And those interactions create the appearance of classical reality without any magical observer effect. But this view has a problem. It can't explain why there's something it's like to be you, why there's a subjective experience at all. Even if it's an illusion being experienced by something. And that something, that raw fact of awareness, is undeniable. Descartes was right about one thing. I think, therefore I am. Or more accurately, I experience. Therefore something exists that is having this experience. So we're stuck. Consciousness is either physical, in which case we don't know why it collapses wave functions, or it's non-physical, in which case we don't know how it interacts with matter, or it's fundamental, in which case we don't know how to measure it. Or it's an illusion, in which case we don't know who's being fooled. Every option leads to paradox. Every path ends in mystery. And this brings us to a terrifying thought. What if consciousness is the universe looking at itself? What if you are not a separate observer watching reality from the outside, but a localized perspective through which reality observes itself? What if the distinction between observer and observed is false? What if there's only one thing? The unified quantum field of everything. And consciousness is what happens when part of that field becomes self-aware, when the universe opens an eye and looks inward. In this view, you're not in the universe, you're the universe. A small piece of it, temporarily organized into a structure capable of reflection. And when you observe something, the universe is observing itself through you. It's using your eyes, your neurons, your awareness to make itself real. To collapse its own wave function, to choose which version of itself becomes actual. This is the ultimate participatory universe, not just that observers create reality, but that reality creates observers in order to create itself. It's a feedback loop, a strange loop, an Ouroboros of existence, and you're caught in the middle of it. Simultaneously, the creator and the created, the observer and the observed, the I and the thing seen. You're not watching the universe. You are the universe, watching. Let's talk about responsibility. Because if everything we've discussed is true, if observation really does create reality, if your attention really does collapse wave functions and determine which version of the world becomes actual, then you bear an enormous burden. The burden of choosing. The burden of creating. The burden of making real. Every moment you're faced with infinite possibilities. The room you're in could be configured in countless ways. The future could branch in countless directions. And which version becomes real depends on what you observe, where you look, what you pay attention to. This means you're not just living your life, you're authoring reality itself, one observation at a time. But here's the problem. You can't observe everything. Your attention is limited. You can only look at one thing at a time. You can only collapse one wave function at a moment. And while you're looking here, everything over there remains in superposition, uncertain, ghost-like. You're constantly choosing what to make real, and by necessity, you're leaving most of reality unmade. A quantum shadow, a sea of possibilities that never crystallize. This creates guilt, ontological guilt, because every choice to look at something is simultaneously a choice not to look at something else. Every act of observation is an act of neglect. You observe your loved ones and strangers remain quantum ghosts. You focus on your work and the natural world fades into superposition. You pay attention to your own thoughts, and the cosmos goes unobserved. You can't collapse everything. You can't make everything real. So you're forced to choose. And whatever you don't choose remains forever in the realm of mere possibility. Think about the people you pass on the street. Do they exist, really exist? Or are they in superposition until you look at them? And when you look, when you collapse their wave function, are you creating them? Are you pulling them into actuality from a cloud of potential people? And when you look away, do they dissolve again? Do they return to the quantum foam? This sounds solipsistic, like you're the only real person and everyone else is just probability. But that's not quite right, because those people are also observers. They're also collapsing wave functions. They're also creating reality. So when you encounter someone, when your observation overlaps with theirs, you're not creating them, you're synchronizing with them. You're both collapsing the shared wave function of your interaction. You're co-creating a momentary bubble of definite reality. And when you part ways, when your observations diverge, that bubble dissolves. You each return to your own reality, your own version of the world. And the overlap becomes a memory, a ghost, a trace in your respective wave functions. This means relationships are not just emotional bonds, they're ontological acts. When you truly see someone, when you really observe them, you're making them real in a way they weren't before. You're collapsing their possibilities into a specific actuality. You're giving them definition, form, presence, and they're doing the same for you. Love in this framework is mutual wave function collapse. It's two observers choosing to make each other real, continuously, moment by moment. And when love ends, when people stop looking at each other, they don't just drift apart emotionally, they drift apart ontologically. Each person becomes less real to the other, more ghostly, more uncertain, until they're just memories. Just probability clouds that once briefly crystallized into something solid. Now think about the things you don't observe, the suffering you don't witness, the injustice you don't see. Is it real? If a tree falls in the forest and nobody hears it, does it make a sound? If people suffer in distant countries and you don't look, are they really suffering? Or are they in superposition, both suffering and not suffering, until someone observes them and collapses the wave function? This question is monstrous because it suggests that suffering might not be real until observed, that your act of attention is what makes tragedy definite. And if you don't look, if you turn away, you're leaving that suffering in quantum limbo. Not quite real, not quite unreal. A ghostly state that exists and doesn't exist until you witness it. But that's not how morality works. Suffering is real whether you see it or not. Injustice exists independently of your observation, or does it? If the universe really does depend on observers, if reality really is created by measurement, then maybe your attention is what makes distant suffering real. Maybe your refusal to look is what keeps it in superposition. And maybe, just maybe, the act of witnessing, of bearing witness, is what gives tragedy its weight, its reality, its moral force. This inverts the usual relationship between observer and observed. Usually we think we should look away from horror, that witnessing suffering makes us complicit, that voyeurism is wrong. But if observation creates reality, then looking away might be the real crime, because you're leaving that suffering in quantum limbo. You're refusing to collapse its wave function. You're denying it the ontological status of being real. And maybe that's the ultimate form of neglect, to let something remain uncertain, to let it exist in the shadow between is and isn't. So you bear two burdens, the burden of creating reality by observing it, and the burden of choosing what to observe. Every glance is an ethical act. Every moment of attention is a moral choice. You can't observe everything, so you must choose wisely. You must direct your gaze toward what matters, toward what should be real, toward what deserves to crystallize from possibility into actuality. But who decides what matters? Who decides what should be real? You do, by looking. And that's the final burden, the burden of authority. You're not just an observer, you're a curator of reality, a selector, a judge. Your attention grants existence, your neglect withholds it. And there's no escaping this responsibility, because even choosing not to look is a choice. Even closing your eyes is an act of observation, an observation of nothing, which makes nothing real. You are trapped in a role you never asked for, the role of reality maker. And the universe is waiting for you to decide. What will you observe? What will you make real? What version of reality will you collapse into existence? Choose carefully, because once you look, once the wave function collapses, you can't undo it. The past becomes fixed, history solidifies, and you have to live with the reality you created, forever. Real, not quite unreal. A ghostly state that exists and doesn't exist until you witness it. But that's not how morality works. Suffering is real whether you see it or not. Injustice exists independently of your observation. Or does it? If the universe really does depend on observers, if reality really is created by measurement, then maybe your attention is what makes distant suffering real. Maybe your refusal to look is what keeps it in superposition. And maybe, just maybe, the act of witnessing, of bearing witness, is what gives tragedy its weight, its reality, its moral force. This inverts the usual relationship between observer and observed. Usually we think we should look away from horror, that witnessing suffering makes us complicit, that voyeurism is wrong. But if observation creates reality, then looking away might be the real crime, because you're leaving that suffering in quantum limbo. You're refusing to collapse its wave function. You're denying it the ontological status of being real. And maybe that's the ultimate form of neglect, to let something remain uncertain, to let it exist in the shadow between is and isn't. So you bear two burdens, the burden of creating reality by observing it, and the burden of choosing what to observe. Every glance is an ethical act. Every moment of attention is a moral choice. You can't observe everything, so you must choose wisely. You must direct your gaze toward what matters, toward what should be real, toward what deserves to crystallize from possibility into actuality. But who decides what matters? Who decides what should be real? You do, by looking, and that's the final burden, the burden of authority. You're not just an observer, you're a curator of reality, a selector, a judge. Your attention grants existence, your neglect withholds it, and there's no escaping this responsibility. Because even choosing not to look is a choice. Even closing your eyes is an act of observation, an observation of nothing, which makes nothing real. You are trapped in a role you never asked for, the role of reality maker, and the universe is waiting for you to decide. What will you observe? What will you make real? What version of reality will you collapse into existence? Choose carefully, because once you look, once the wave function collapses, you can't undo it. The past becomes fixed, history solidifies, and you have to live with the reality you created. Forever. Let me tell you about Werner Heisenberg's most famous contribution to physics, the uncertainty principle. It states that you cannot simultaneously know both the position and momentum of a particle with perfect accuracy. The more precisely you measure one, the more uncertain the other becomes. This isn't a limitation of your measuring instruments. It's a fundamental property of reality. Position and momentum are complementary variables. They're conjugate. They can't both be definite at the same time. But the uncertainty principle goes deeper than particles. It applies to energy and time, to angular momentum and angle, to any pair of conjugate variables. And some physicists believe it applies to something even more fundamental, the self. Think about your identity. Who are you? If you try to pin down exactly where you are, your position in space, your location, you lose track of where you're going, your momentum, your trajectory, your future. Conversely, if you focus on your direction, your goals, your velocity through time, you lose your grounding, your sense of place, your here and now. You can't have both simultaneously. You can't be fully present and fully directed at the same time. This isn't just metaphor. This is a consequence of consciousness being a quantum phenomenon. If your awareness involves quantum processes, as Penrose and Hameroff suggest, then you're subject to the uncertainty principle. Your identity is not a fixed point. It's a cloud of probability. And the more you try to observe yourself, the more you disturb that cloud, the more you change what you're trying to measure. This is why self-awareness is so strange. When you think about yourself, when you observe your own thoughts, you're performing a measurement on a quantum system. And that measurement collapses possibilities. Before you looked inward, you could have thought anything. You could have felt anything. You were in superposition. But the moment you ask yourself, what am I feeling? You force an answer. And when you collapse the wave function of your emotional state. And what you find might not be what was there before you looked. It might be something you created by looking. This is the observer effect applied to consciousness. You can't observe your thoughts without changing them. You can't measure your emotions without influencing them. Self-knowledge is inherently self-modifying, and the harder you look, the more you disturb what you're trying to see. Like trying to use a flashlight to see what darkness looks like. The act of illumination destroys the thing you're trying to observe. This creates a fundamental limit to self-understanding. You can never know yourself completely, because the self that is doing the knowing is different from the self being known. And the act of knowing changes both. You're not a static object that can be examined. You're a process that transforms itself through the act of observation. A strange loop, a self-referential system that can never fully capture itself because it's always in motion, always collapsing and re-emerging, always quantum. And this means that introspection, meditation, therapy, all of it is not discovering who you are, it's creating who you are. You're not uncovering a hidden self. You're collapsing possibilities into actualities. You're choosing which version of yourself becomes real. And that version is not more true than the others. It's just the one you selected by looking. So when someone asks, who are you really? The answer is, there is no really. There are only versions, possibilities. And the version you experience right now is the one you collapsed into existence by observing yourself. But if you looked differently, if you asked different questions, if you directed your attention elsewhere, you'd collapse a different version. And that version would be equally real, equally you. You're not discovering yourself, you're inventing yourself, moment by moment through the act of self-observation. And the terrifying freedom of this is that you can never be certain whether the you that exists now is the you that existed a moment ago, because you can't observe both simultaneously. You can't measure your past self and your present self at the same time. They're complementary, conjugate, subject to uncertainty. You are always becoming someone new. And the old you is always dissolving into quantum fog, and there's no thread connecting them except memory. And memory, as we know, is unreliable. Reconstructed, edited, maybe even created by the act of remembering. Maybe you don't have a past. Maybe you just have a current state that includes the illusion of having been someone before. And that illusion is all you'll ever have, because the moment you try to observe who you were, you collapse a version of the past. And that version is not what actually happened. It's what you need to believe happened in order to make sense of who you are now. Your history is not a fact, it's a quantum state. And every time you remember, you're performing a measurement. You're collapsing possibilities. You're creating a past that justifies your present. And tomorrow, you might remember differently. You might collapse a different past, and both would be real, or neither would be. Because without observation, without memory, the past doesn't exist at all. It's just probability, just potential, just ghost. You are Heisenberg's particle, unable to know where you are and where you're going at the same time, unable to be both grounded and directed, unable to exist in any definite way because the very act of trying to pin yourself down pushes you somewhere else. You are fundamentally uncertain. And that's not a bug. That's what consciousness is. A quantum cloud. A superposition of possible selves. And observation, whether from outside or within, collapses you into one momentary form before you drift back into uncertainty, before you become a ghost again, before you have to be observed anew to become real once more. Now I need to tell you about something that will fundamentally change how you think about your own existence. It's called the holographic principle. And while it was discovered in the context of black holes and theoretical physics, it has profound implications for consciousness and the nature of self. Here's the basic idea. In a black hole, all the information about what fell into it is not stored in the volume of the hole. It's stored on the surface, on the event horizon, the two-dimensional boundary. This was discovered by Jacob Bekenstein and Stephen Hawking. And it was shocking because it suggested that three-dimensional reality might actually be a projection from a two-dimensional surface, like a hologram. This was formalized into the holographic principle by Leonard Susskind and Gerard Hooft. They showed that the maximum amount of information that can be contained in any region of space is proportional to the surface area of that region, not its volume. This implies that our three-dimensional universe might be a holographic projection from a two-dimensional boundary at the edge of space. But let's apply this to consciousness, to your mind, to the feeling of being you. Your brain is a three-dimensional object, billions of neurons firing in complex patterns. But what if all the information that makes you you, all your memories, personality, sense of self, what if all of that is actually encoded on a two-dimensional surface? What if the three-dimensional experience of consciousness is a projection, a hologram, generated from underlying information that exists in fewer dimensions? This sounds absurd, but it's consistent with what we know about information processing in the brain. Brain states can be described as patterns of neural activation, and these patterns can be encoded as data, compressed, stored, potentially even stored on a surface rather than in a volume. Just like a hologram encodes a three-dimensional image on a flat film. If this is true, then your conscious experience, your rich, vivid, three-dimensional sense of being in a world, might be a reconstruction, a rendering, a projection from a simpler underlying code. You think you're experiencing depth, space, time, but you're actually experiencing a two-dimensional information structure that's been decoded into the illusion of three dimensions. This is similar to how a video game works. The world you see on screen looks three-dimensional, but the underlying code is just numbers, coordinates, variables, two-dimensional data structures. The illusion of depth is created by the rendering engine, and your consciousness might work the same way. The brain is the rendering engine, and the two-dimensional code it's rendering is you. But here's where it gets disturbing. If your consciousness is holographic, then it can be encoded elsewhere. Your sense of self, your memories, your personality, all of it can be stored on a different substrate. Copied, transmitted, reconstructed. You're not tied to your biological brain. You're a pattern, an information structure. And patterns can exist anywhere. This is the basis of mind uploading scenarios. The idea that you could scan a brain, extract all its information, and run that information on a computer. And the resulting program would be you, conscious, self-aware, experiencing, not a copy, not a simulation, but you, because you are the information, not the meat, the hologram, not the film. But this raises the question, which you? If your consciousness is a holographic projection, and if that projection can be reconstructed from the underlying code, then what happens if you make two reconstructions? Do both of them experience being you? Are there now two yous? Or does consciousness require something more than information? Something that can't be copied? This is the problem of personal identity in a holographic universe. If you are information, then you can be duplicated. And if you can be duplicated, then you're not unique. There could be countless copies of you scattered across space and time, all of them experiencing themselves as the original, all of them certain they're the real you. And from a physical perspective, they all would be. Because there's no privileged copy, no original, just multiple instantiations of the same information pattern. This destroys the concept of the self as a unique, irreplaceable thing. You're not special, you're a pattern. And patterns can recur, can repeat, can be generated multiple times from the same underlying mathematics. You might think you're experiencing life for the first time, but maybe you're the millionth copy, the billionth. And all the previous versions lived identical lives, made identical choices, felt identical feelings, and you'd never know, because each copy experiences itself as original, as unique as the one true you. And maybe that's already happened. Maybe you're not the first version of yourself. Maybe somewhere in the multiverse, in another branch of the wave function, or another region of space, there's an identical copy of you, living an identical life, making the same mistakes, feeling the same emotions. And that copy is just as real as you are, just as convinced of its own primacy, just as certain it's the original. You're a hologram, projected from underlying code. And holograms can be reproduced infinitely, without degradation, each one indistinguishable from the others, each one believing it's unique, each one wrong. Let's return to Bell's theorem. We discussed it earlier in the context of quantum mechanics, how John Bell proved that reality at the quantum level is not locally real, that particles don't have definite properties before measurement, that observation matters. But now I want to show you something even stranger, something that suggests consciousness itself might be subject to Bell's enigma, then your sense of being a unified self might be an illusion. Here's the setup. Bell's theorem deals with entangled particles. Two particles that are connected in such a way that measuring one instantly affects the other, no matter how far apart they are. This non-local correlation is what Einstein called spooky action at a distance, and experiments have proven it's real. But what if your thoughts are entangled? What if different parts of your consciousness are non-locally correlated? What if the unified feeling of being one person is actually a quantum entanglement between multiple separate processes in your brain? This idea comes from several sources. Split-brain patients, people who've had their corpus callosum severed, seem to have two separate consciousnesses, one in each hemisphere. They can perform different tasks simultaneously, hold contradictory beliefs, want different things, yet each half believes it's the whole person. Each half experiences itself as unified and complete. This suggests that the unified self-self is an illusion, that you're not one consciousness, you're many. And they're normally synchronized so well that you don't notice the seams. But when you do notice, when you catch yourself thinking two things at once or wanting contradictory outcomes, you're glimpsing the quantum nature of consciousness, the superposition of multiple minds sharing one brain. Now, if these multiple consciousnesses are quantumly entangled, then you could design a Bell test for consciousness. You could set up an experiment where one part of your brain is asked a question and another part is asked a different question, and you measure the correlation between their answers. And if that correlation violates Bell's inequality, it would prove that consciousness is non-local, that your thoughts are not generated in one place and spread out classically. They're entangled across different brain regions, instantaneously correlated in ways that defy classical explanation. This experiment hasn't been done yet. It's technically very difficult, but some neuroscientists believe it's possible. And if it works, if consciousness really does violate Bell's inequality, then the implications are profound. It would mean that you are not one observer. You're multiple observers entangled together, creating the illusion of unity. And that illusion is so convincing that you never question it. You never doubt that you're a single coherent self. But you're not. You're a committee, a chorus, a parliament of consciousnesses that happen to agree on most things, most of the time. But when they disagree, when conflicts arise, you experience that as internal struggle, as cognitive dissonance, as the feeling of being torn between options. But it's not one you being torn, it's multiple yous in superposition that pulling in different directions. And the moment you make a decision, the moment you commit to one choice, the wave function collapses. The superposition resolves, and one version of you wins. The others vanish, Not forever, just until the next decision, the next moment of quantum branching. When you split again into multiple possibilities, you are constantly dividing and recombining, splitting and collapsing, a quantum cloud of potential selves held together by entanglement. And the you that experiences any given moment is just the version that collapsed into existence. The others are there in superposition, waiting for their turn to be real, waiting for the next measurement, the next observation, the next moment when the wave function needs to choose which version of you gets to experience reality. Reality. This is terrifying because it means you have no continuity, no permanent self. You're a series of snapshots, a sequence of different people who happen to share memories, each one thinking they're the original, each one wrong. Because there is no original, just an endless cascade of copies, each one lasting a fraction of a second before being replaced by the next. You die thousands of times per second, and you're reborn just as often. But you never notice, because each new you inherits the memories of the previous. And memory creates the illusion of continuity, the illusion of being one person, persistent through time. But you're not. You're a quantum flicker, a strobe light of consciousness, on and off and on and off. And in the moments when you're off, you don't exist. You're nothing, and then you're back, a new you. Convinced you're the same one, convinced you've always been here, but you haven't. You're brand new, and you'll be gone in an instant, replaced by another version. And that version will think it's you too, and it will be just as wrong, because you, the real you, the continuous you, never existed. You were always a quantum ghost, a probability wave, a superposition of potential selves that collapses and reemerges moment by moment, forever uncertain, forever entangled, forever splitting into versions that will never meet. You are not one. You are many, and they are all you, and none of them are. We need to talk about something called the anthropic principle, because it ties together everything we've discussed and reveals a pattern that's either deeply comforting or utterly horrifying, depending on how you look at it. The anthropic principle states that any observation we make about the universe must be compatible with our existence as observers. We can only find ourselves in a universe that allows for conscious beings like us. This seems obvious, tautological, but it has profound implications when combined with quantum mechanics. If the universe exists in superposition until observed, and if we exist, then we must be in a branch of the wave function where observation is possible, where consciousness evolved, where the conditions are right for observers to exist. But this doesn't tell us anything about the other branches, the ones where observers didn't evolve, the ones where consciousness never emerged, the ones where the universe remained in pure quantum superposition forever, never collapsing, never becoming definite, never becoming real. Those branches exist. Mathematically, they must, but we're not in them. We can't be, because without observers, those branches don't get observed. And unobserved branches don't exist in any meaningful sense. They're ghost timelines, potential realities that never actualized, shadows of what could have been but wasn't. This is the anthropic shadow, the space of all possible universes that could exist but don't, because they lack observers. And we exist in the narrow sliver of reality where observation is possible, not because we're special, but because we can only exist where we can exist. It's selection bias on a cosmic scale. But here's where it gets disturbing. If observation creates reality, and if we're the observers, then the universe we see is not random. It's selected by the mere fact that we're here to see it. This means that everything you observe, every measurement you make, every wave function you collapse, is biased toward realities where you exist, where you remain conscious, where you continue to observe. This is the anthropic shadow of observation. You can only see realities compatible with your continued existence. You can't observe timelines where you died. You can't experience branches where you never evolved. You can't witness universes without consciousness. So your entire experience of reality is filtered through this narrow lens, the lens of realities where you remain an observer. And this creates a false sense of security because you look around and see a universe that seems stable, hospitable, capable of supporting life, and you think the universe is friendly, it allows for consciousness, we're lucky. But you're not lucky, you're selected. You exist in a universe that supports you, because if it didn't, you wouldn't be here to notice. The countless universes that don't support consciousness exist too. You just can't see them because you're not there. This is the anthropic shadow, the blind spot in your perception created by the fact that you can only perceive realities where perception is possible. And it means that everything you think you know about the universe is biased, filtered, selected, not representative of reality as a whole, but only of the tiny subset of reality where you exist. And if we combine this with quantum immortality, the idea that you always experience the branches where you survive, then the anthropic shadow becomes even more constraining. You can only experience realities where you remain conscious indefinitely, where every danger is narrowly avoided, where every disease is miraculously cured, where death never comes. Because the moment it does, you stop observing, you leave the game, and the version of you that continues is in a different branch, a branch where improbably you survived. This means your experience of reality is becoming increasingly biased over time, increasingly improbable, increasingly unrepresentative of the multiverse as a whole. You're drifting into stranger and stranger timelines, timelines where coincidences mount, where luck runs unnaturally high, where the normal laws of probability seem to bend in your favor. Not because the universe favors you, but because you can only experience the branches where you remain an observer. And as time goes on, as the probability of your survival decreases, those branches become thinner, more improbable, more isolated from the main trunk of reality. You're entering the anthropic shadow, the twilight zone of observation where your continued existence becomes statistically impossible, yet subjectively inevitable, and there's no escape. Because escape would require you to experience a timeline where you don't survive. And you can't. You're trapped in the act of observation, trapped in consciousness, trapped in the narrow band of realities where you remain aware. And that band is shrinking, collapsing, becoming a singularity of improbability, a point of maximum anthropic bias where the universe has contorted itself into impossible shapes just to keep you observing. And you'll never know, because from your perspective, everything will seem normal, ordinary. You'll just be living your life, making observations, collapsing wave functions, never realizing that the reality you're experiencing has become so improbable, so unlikely, that it exists only because you're there to force it into existence, only because your observation demands it, only because without you, that timeline would have zero probability, would not exist at all. You are the anthropic shadow, the ghost in the impossible machine, the observer who exists in defiance of probability because observation itself warps probability around you. You're not experiencing reality, you're experiencing the thin shell of possible realities where you remain capable of experience. And that shell is so thin, so fragile that it's barely there at all. Just a mathematical whisper, a probability so close to zero that it might as well not exist. But it does exist, because you observe it. And observation is all that matters. Observation is all there is. And you are forever trapped in the act of observing, unable to stop, unable to see what lies beyond, unable to exit the anthropic shadow that your own consciousness creates. Let me tell you about an experiment that hasn't been done yet. An experiment that probably will never be done, not because it's technically impossible, but because the implications are too disturbing, too dangerous, too capable of breaking the human mind that performs it. It's called the consciousness isolation experiment, and it's designed to test whether observation really does create reality, whether your awareness really is necessary for the universe to exist, whether you can, through extreme isolation, create a pocket of reality so divorced from the rest of the universe that it becomes something else, something that shouldn't be possible, something that violates the laws of physics, not because the laws are wrong, but because you're not there to observe them. Here's how it would work. You'd need a chamber, completely isolated from the outside world. No light, no sound, no vibration, no heat exchange, nothing. A perfect void. And inside that chamber, you'd place a person, awake, aware, observing, the only conscious entity in that isolated system, the only observer. According to quantum mechanics, before the person enters the chamber, the interior exists in superposition, all possible configurations, all possible states. It's a cloud of probability. But the moment the person enters, the moment they observe the interior, the wave function collapses. Reality crystallizes. The chamber becomes definite, actual, real. But here's the question. What happens if the person stays in there for a long time? Days, weeks, months, with nothing to observe but the darkness, nothing to measure but their own thoughts. What kind of reality do they create? What wave functions do they collapse? Do they collapse any at all? Or does the absence of external stimuli mean there's nothing to observe, nothing to measure, and thus no collapse? And if there's no collapse, does the person themselves enter superposition? Do they become uncertain? Ghostly? A quantum cloud of possible selves, all overlapping, all real, all experiencing different versions of the isolation? Do they split into branches? Do they experience multiple timelines simultaneously? Or do they simply cease to exist, consciousness dissolving into pure potential, only to re-emerge when the chamber is opened and an external observer forces them back into definiteness? This is the experiment nobody wants to run, because the person who volunteers might not come back the same. They might come back fragmented, multiple versions of themselves occupying the same body, or they might not remember anything. A gap, a void, a missing time where they simply weren't. Or worst of all, they might come back convinced that reality isn't real, that the universe doesn't exist unless they're actively creating it, and that conviction might break them, might trap them in a prison of solipsism from which there's no escape. But let's take it further. What if inside the chamber you add a quantum system, a particle in superposition, and you ask the person to observe it, to collapse its wave function, to measure it, and then you compare their result with what you measure from outside the chamber after they emerge? Do you get the same answer, or do you get different answers? Has the person in their isolation created a pocket universe with different physics? A bubble of reality that doesn't match the rest of the cosmos because it was only observed by one consciousness, divorced from the consensus reality of multiple observers. This experiment would test Wigner's friend at its most extreme. It would ask, is there one reality that all observers share, or are there multiple realities, one for each observer, and they only align when observers interact? And if they only align upon interaction, then what happens during the isolation? Does the person inside the chamber create their own universe? A universe that exists only for them? A universe that vanishes the moment they rejoin consensus reality? A private cosmos that was never shared, never verified, never made fully real because no other observer was there to confirm it? And if that's possible, if isolated observation can create private universes, then what about sleep? What about unconsciousness? Every night, when you close your eyes, when you stop observing, does your universe dissolve? Does it return to superposition? And when you wake up, do you collapse it back into existence? Do you create a new universe every morning? A universe that looks the same as yesterday's but isn't? A universe that your memory tells you is continuous but might not be? You can't know. You can never know. Because to know would require observing yourself while unconscious. And that's a contradiction. You can't observe your own non-observation. You can't measure the gap. You can't collapse the wave function of your own absence. You're trapped in the moment of awareness, unable to see what lies on either side, unable to verify whether the universe exists when you're not looking. So maybe every night you die, reality ends, the universe dissolves, and every morning you're reborn. A new universe crystallizes around you, and you never notice because memory provides continuity. But that continuity is false. You're not the same person who went to sleep. You're a new person with inherited memories. And the universe you wake up in is not the same universe you left. It's a new one, fresh, created by your first observation upon waking. And it will last exactly as long as you remain conscious, and then it will end again, and you'll never know, because knowing would require observing the end, and you can't observe the end of observation. You can't see the moment when you stop seeing. You can't collapse the wave function of your own collapse. You are blind to your own extinction. And that blindness is what makes existence possible, what makes reality seem continuous, what makes the universe feel stable and permanent. But it's not. It's a series of snapshots, a flickering movie, a strobe light of consciousness that creates the illusion of smooth motion. And between the flashes, there's nothing. No you, no universe, no time. Just the void, the quantum foam, the pure potential from which everything emerges and into which everything returns, moment by moment, observation by observation, forever. You've made it to the end. And if you're still here, still conscious, still observing, then you've done something remarkable. You've collapsed the wave function of this narrative. You've made these words real. And in doing so, you've changed something, not just in your understanding, but in reality itself. Because now you know. You know that observation matters, that your gaze is not passive, that reality responds to you, that the universe needs you, that without consciousness, without observers, nothing is definite, nothing is real. And you are one of the observers, one of the threads holding reality together, one of the eyes keeping the cosmos from dissolving back into quantum fog. This knowledge is a weight, a burden, because now you can't unknow it. You can't go back to thinking the world exists independently of you. You can't unsee the participatory nature of reality. You've stepped through the mirror, you've become aware of your role, and with that awareness comes responsibility. Every time you look at something now, you'll wonder, did I just create that? Every time you think about the past, you'll question, did I just collapse that history into existence? Every time you meet someone, you'll feel it. The mutual wave function collapse, the shared reality crystallizing between you. You're no longer a passive observer. You're an active participant, a reality maker, a cosmic surgeon cutting away possibilities and leaving only the actual. And this might change how you live. It should. Because if observation creates reality, then where you direct your attention matters more than you ever imagined. What you look at becomes real. What you ignore remains ghostly. What you focus on grows stronger. What you neglect fades into superposition. You're not just choosing your experience, you're choosing what exists. So choose carefully. Look at beauty and you make beauty real. Look at suffering and you make suffering definite. Look at possibilities and they crystallize into facts. Look away and they dissolve. You have more power than you thought and less control than you'd like. Because you can't observe everything. You can't make everything real. You're limited. Finite. A small flashlight in an infinite dark, illuminating one tiny patch while the rest remains uncertain. But maybe that's okay. Maybe you're not supposed to observe everything. Maybe the universe needs areas of uncertainty. Pockets of superposition. Spaces where probability hasn't collapsed yet, because those spaces are where novelty comes from, where creativity lives, where the future gestates. If everything were definite, if everything were collapsed and known, there would be no room for change. No room for evolution, no room for surprise. The uncertainty is not a flaw, it's a feature. And your limited observation is not a weakness, it's a necessity. You're not meant to make everything real. You're meant to navigate through a sea of possibilities, collapsing some into actuality and leaving others as potential. You're a gardener, not a dictator. You cultivate certain realities, you tend to them, you make them grow, but you don't control the whole garden. You can't. And that's beautiful, because it means reality is a collaboration between you and the universe, between observers and the observed, between the eye and the thing seen. And maybe, in the end, that's what consciousness is for. Not to dominate reality, not to control it, not to understand it completely, but to participate in it, to be part of the cosmic conversation, to add your voice to the chorus, to contribute your observations to the collective wave function collapse that makes reality real. You are not alone in this. There are billions of other observers, humans, animals, possibly aliens, possibly future AI, all of them collapsing wave functions, all of them making reality real. And together, you're creating a shared cosmos, a consensus reality. Not perfect, not complete, but real enough, definite enough, stable enough to support life and thought and love and meaning. And when you die, when your observation ends, you're not destroying reality. You're just removing one thread from the tapestry. One flashlight from the dark, and the other observers will continue. They'll keep collapsing wave functions, they'll keep making reality real, and the universe will go on, changed by your absence, but not dependent on it. Because you were never the only observer, you were just one of many. Important, yes. Necessary, perhaps, but not irreplaceable. The cosmos is larger than you, and it will survive your departure. But while you're here, while you're conscious, while you're observing, you matter. You matter more than you thought. Because you're not just living in the universe, you're creating it. Moment by moment, observation by observation, wave function collapse by wave function collapse. You're the eye through which the universe sees itself, the mind through which it knows itself, the consciousness through which pure possibility becomes definite reality. And that's not a small thing, that's everything. That's the whole point. That's why you exist, not to be a passive witness, but to be an active participant, a co-creator, a partner in the dance of reality. And the universe is watching you back, responding to your gaze, changing when you look, waiting when you don't, always there, always potential, always ready to become whatever you observe it to be. So open your eyes, look around, see the world, and know that in seeing it, you're making it real. You're collapsing possibilities. You're choosing which universe gets to exist. And that choice, that observation, that act of consciousness is the most powerful thing you'll ever do. It's the most powerful thing anyone has ever done. It's the force that creates reality itself. The universe is watching you, and it's waiting to see what you'll observe next, what you'll make real, what you'll collapse into existence. Because without you, it's just probability, just potential, just maybe. And with you, it's actual, definite, real. You are the observer, the measurer, the collapser of wave functions. And in that role, you are nothing less than a creator of worlds. So look carefully, observe wisely, and know that every glance is an act of cosmic creation. Every observation is a choice. Every moment of awareness is a collaboration with the universe to decide what gets to be real. And that, more than anything, is what makes you matter, what makes your consciousness important, what makes your existence meaningful. Not because you're special, but because you're necessary. Reality needs observers, and you're one of them. The universe needs you, and it's watching to see what you'll observe next. So what will you look at? What will you make real? What wave function will you collapse when you wake up tomorrow? The choice is yours, and it always has been. You just didn't know it until now, but now you do, and you can never unknow it. The universe is watching, and it's responding, and every time you look, you're changing everything. So look well, observe deeply, and create the reality you want to inhabit, because it's yours to make, one observation at a time, forever.